Hi, I'm Ramon Miranda, your host for Chemistry in Action. In the past 2 episodes, we looked into measurements. Today, we will begin to discuss how to classify matter. Let's start out with mixtures. Let's find out what makes mixtures different from other kinds of matter. Mixtures are all around us, in everything we do every day. In eating or drinking, cooking or cleaning, we always see and use mixtures. Let's look for mixtures in this food center. We make halo-halo by mixing bananas, beans, gulaman, sago, leche flan, sugar, milk, and ice. We make fruit drinks basically by mixing fruit bits with sugar, water, and ice. See these 2 men preparing coffee? They both have the same amount of water and coffee in their cups, but one adds twice as much sugar as the other. This makes the 2 drinks differ in composition. The drink with more sugar tastes sweeter than the other, but in both cases, the properties of each ingredient, the sugar, coffee, and water, is found in the mixture that is a coffee drink. How much the properties of each ingredient appears in the mixture depends on the relative proportions of each ingredient. The mixtures that we have just shown have ingredients that are themselves mixtures and not substances. Much simpler are those mixtures made up of 2 or more substances. Gold jewelry, for instance, is basically a mixture of 2 substances, gold and copper. Mixtures are combinations of 2 or more substances in varying proportions. The combinations do not involve chemical reactions. All the properties of the mixture are a blend of the properties of each component. You will find many mixtures at home too. Some of these we have already come across in our past episodes. Vinegar, for example, is a mixture of about 95% water and 5% acetic acid. And then, drinking water itself. Drinking water is a mixture of pure water, dissolved minerals and gases, and some impurities. These dissolved substances give drinking water its distinct taste. We can see how water is a mixture when we boil or distill it. Observe the dissolved gases coming out from the boiling water. High temperature causes the gases to escape from the water. In distilling water, we boil it to change it into vapor. Then, we cool the vapor to change this back into liquid. Notice the scum or dissolved minerals in water deposited on the walls of the distillation apparatus after the liquid is turned into vapor. Muriatic acid is a mixture of hydrochloric acid and water. It is sometimes used for cleaning tiles and toilet bowls. Soil is a mixture of sand, silt, clay, humus, and millions of bacteria, fungi, algae, and tiny living organisms. Gasoline, which powers vehicles, is a liquid mixture of different hydrocarbons, including octane, hexane, and decane. Air is a gaseous mixture. Its principal components are nitrogen and oxygen. Other gases in the air are carbon dioxide, water vapor, and small amounts of noble gases like argon, neon, helium, and xenon. We have seen some examples of mixtures we encounter every day. Thousands more exist around us and within us. How can we simplify the study of mixtures? By classifying. We can classify mixtures into three kinds according to their particular characteristics. We will look at the three types of mixtures after we pause for some reminders. Some of the mixtures you saw, like guayabana drink, are those of a solid and a liquid. The solid does not dissolve. If you shake the mixture, you get a suspension. You can easily see the bits of guayabana even after shaking. Later, these suspended solids settle to the bottom of the mixture. A second kind of mixture is a solution. Commercial vinegar is a liquid solution. Look at this vinegar. Do you see any solid particles in this mixture? No, because in a true solution, the solids mixed in the liquid are now dissolved completely. The part of the solution that is dissolved is called the solute. In the case of the vinegar solution, acetic acid is a solute. The dissolving medium is called solvent. In the vinegar solution, water is a solvent. Usually, the mass of the solvent is much greater than that of the solute. Other liquid solutions are muriatic acid, bleaching liquid, and gasoline. Not all